When you think about cracking the biggest mysteries of the universe, we usually picture these futuristic, powerful telescopes, right? But what if I told you some of the most important clues are actually hiding in the past? It's true. To figure things out, astronomers are looking in two directions at once. Forward, with amazing new technology, and backward, digging through dusty archives full of forgotten data from 100 years ago. And that really gets to the heart of the matter. I mean, think about it. How do you make a movie that's 100 years long? Because that's really what we need. The universe isn't some static photograph. It's constantly changing. To really understand what's going on out there, you can't just look at a snapshot from today. You have to see the whole story unfold. So, let's jump into our story. And like any good detective novel, this one starts with a cosmic cold case. We're talking about a really puzzling object out there in space that just wasn't making any sense with the modern data we had. Okay, meet the main suspect, OJ287. Now, this isn't just one thing. It's a pair of supermassive black holes, and they're locked in this incredible gravitational dance that will eventually cause them to merge. For years, astronomers were just scratching their heads. This system would suddenly flare up and get super bright, but the timing of these flares seemed totally random. They knew they were missing something. They needed a longer timeline, more data points, to finally crack the code. So where did they find that crucial clue? You'd think it would be from some shiny new space telescope, right? Nope. It was in these old, hand-annotated photographic glass plates from the early 1900s. They were just sitting in these dusty cabinets, looking more like a vintage record collection than priceless scientific data. And the detective work here was just incredible. An astrophysicist named René Hudek went through more than 2,000 of these plates, one by one, with a magnifying glass. He managed to find usable data that went all the way back to 1896. And in the process, he found a bunch of flares that nobody even knew had happened, including a massive one back in the year 1900. This old data was the missing piece. It allowed them to finally build a model that explained the physics of this bizarre black hole dance. Case closed. Now, the story of OJ287 is super cool, but it's really just one example of a much bigger idea. The universe isn't static, not at all. It's a dynamic, ever-changing place, and there's an entire field of science dedicated to studying it. That field is called time-domain astronomy, and it's pretty much exactly what it sounds like. It's the study of how everything out there changes over time, whether those changes are super fast and explosive, or slow and subtle, taking place over seconds or days, or even centuries. So these changes tend to fall into two main camps. On one side, you have the things that go bang, what astronomers call transients. These are the sudden, one-and-done events, like a star exploding in a supernova. On the other side, you have things that fluctuate, or variables. These are objects that change their brightness over and over, like pulsating stars or, yeah, you guessed it, active black holes, like our friend OJ287. So, if the past was all about painstaking, hands-on detective work with glass plates, the present? Well, the present is about dealing with an absolute flood of digital information. To really see how much has changed, just look at this. On the left, you've got an astronomer in the early 20th century. On the right, the Vera C. Rubin Observatory in Chile, the absolute cutting edge of time-domain astronomy. But here's the wild part. The basic technique is exactly the same. You're still just comparing pictures of the sky from different times to see what's changed. The difference is the scale, which is just staggering. How staggering are we talking? Well, the Rubin Observatory will collect 20 terabytes of data every single night. To put that into perspective, that's more information in one evening than many of those historic archives collected in an entire century. The real challenge, though, is sorting through all that. Software is going to automatically compare images and send out alerts whenever something changes. Over its 10-year survey, the observatory is expected to send out more than 20 billion of these alerts. It's going to be an absolute torrent of cosmic change notifications. And this is where our story really comes full circle. See, the true power isn't just in all the new data. It's in combining that digital flood with over a century of these historical observations. This is the ultimate goal. By stitching together the old glass plates with the new digital surveys, astronomers can finally create that century-long movie of the sky. And that movie will let them see patterns and events that are totally invisible on shorter timescales.
And we just can't forget the human element in all this. It isn't just about data points. It's about dedicated scientists like Rajka Jordana Shapich. She described her process: listening to opera with thousands of plates on her table, peering through a microscope for hours on end, meticulously measuring the brightness of stars by eye.
It's that kind of hands-on tactile work that built the foundation of our cosmic understanding. As astronomer Bradley Schaefer puts it, a single image from a modern space telescope is just one data point, but the real story is told over the century.
But this brings us to a really crucial and urgent problem. This invaluable historical record, our only window into the cosmos of the past, is at risk of disappearing forever. There are about 10 million of these glass plates scattered in archives all over the world. But they are fragile. Glass cracks. The chemical emulsion that actually holds the image can peel right off. And tragically, entire collections have been misplaced or even just thrown in the garbage. Every single plate that's lost is a piece of cosmic history that is gone forever. Astronomer Elizabeth Griffin, who once watched the emulsion literally fall off a plate as she picked it up, puts it simply: the data these plates hold is irreplaceable. And that's why preserving them and digitizing them has become this desperate race against time. Which leaves us with one final fascinating question. We solved the mystery of OJ287 by looking back in time. So what other cosmic secrets, what other clues to the universe's greatest puzzles are just sitting there right now, waiting to be rediscovered in these glorious stacks of glass?